Early on in algebra, you're going to be asked to be able to find the degree of an equation. And I remember when I first learned this thinking they're questioning my intellect here because this seems to be so basic, but it also seems to be useless. It almost just seemed like busy work to me because all it is, the degree of an equation, when you have a standard form equation written in the form of a to the x to the n plus b to the x to the n minus 1, and if you keep going, you're going to have an n minus 2 and an n minus 3. That's a fancy way of saying that whenever we have these x values, we're going to put them in order of the degree of our x values. So in this case, since x to the fourth is our greatest x, we're just going to now descend by 1 every time. Now your b may be 0, so you may skip an x cubed term, but the degree of this equation is going to be 4. Now, that's very simple because really all you're looking for is what's my greatest exponent on my x term, and it just doesn't seem to be all that helpful. But it does help you understand how many solutions you should be looking for. So for example, if we have the equation where we're setting all of this equal to 0, what that's saying is if we put this on the x-axis, we're setting it equal to 0, we want to know where our y0, or in other words, where is this crossing our x-axis? Now, we know that if the degree is 2, we're going to end up with some sort of parabola. Okay, so if the parabola crosses the x-axis, we know it's going to cross the x-axis in 2 places, unless your vertex is sitting right here on the x-axis, simply because that's considered a double term or a double solution because you're approaching it from both directions. On an x cubed term, it's possible now that we're going to have 3 solutions. An x fourth, it's now possible we're going to have 4 solutions, and you can figure out that whatever the degree of your equation is, you can expect that you're going to have up to that many solutions. Now, in reality, you're going to have exactly that many solutions if we include imaginary numbers or complex numbers. It does not mean if we have an equation, in this case, to the 4th degree, it doesn't mean that we're going to find 4 real solutions. It does mean we're going to find 4 solutions, but that may include some of the imaginary numbers. That means you're going to find, for example, under your square root, you're going to take the square root of a negative number. That introduces imaginary numbers, and those are considered solutions. But the nice thing about this is imaginary numbers or complex numbers always come as solutions in pairs of 2. So for example, if we have x cubed, since imaginary numbers or complex numbers are always going to come in pairs of 2, it's possible that we could have 2 complex answers, but that means we're always going to have at least 1 real answer simply because they have to come in 2s if they're not real numbers. And if we have 3 solutions, the only way that can happen is if you have a complex number, you're going to have exactly 2 complex numbers and a real solution. Now that makes sense because you'll notice that our x squared term, it's possible since both of these are heading off to infinity in the same direction, it's very possible that that's happening without ever crossing the x-axis. But in all of our odd termed degrees, you're going to be heading off to infinity in different directions, which means it's always going to cross that x-axis at least once. And so that makes sense when you consider the imaginary terms always come in pairs. So understanding what's happening with the degree of the equation will give you an idea of what it is that you're looking for when you are, well, 1, while you're graphing, you know how many times it's going to change direction, but 2, you know how many answers you're looking for and what those answers might look like if you're introducing complex numbers into those solutions and why they show up in pairs. So understanding the degree of an equation really can be helpful. This is also why we get extraneous answers periodically when we're solving equations. Because, for example, let's say we've got an equation and we need to come up with a solution. We've got to square both sides. Well, we've just messed with the degree of that equation. We've made it look different. We've kept everything equal on both sides. But we may have introduced now, since we've increased the degree of that equation, we may have introduced additional solutions that don't fit our original equation. And so if that's the case, we've got to check for our answers to make sure that they fit the original equation. It doesn't mean you've done anything wrong if you come up with these extraneous solutions. All it means is that you've done some things with the equation that in order to solve it easier, you've had to change the degree of the equation to get that to fit. And so always make sure you go to your original equation to make sure that those solutions fit, simply because of this understanding what it means when we're looking at the degree of an equation. And that gets a little more complicated when you're introducing square roots or cubed roots or anything else into that equation. It makes it a little more difficult to see what's going on. But get in the habit of looking for the degree of an equation when you're trying to come up with solutions or when you're needing to graph, just to give you an idea of what that graph is going to look like and how many solutions you should be looking for. If these are helpful to you, please like and subscribe. As always, pass this information on to those that it may be useful for. And as always, thanks for watching.